Okay, let's look at the second half of the review. So sine of 3 pi over 4. First thing we do is say what quadrant. Well, pi we're going to think of as 4 pi over 4. So we get over here, there is 1 pi left, 1 pi over 4 left. So this would be 3 pi over 4, because we know that step 1 is to find the reference angle. Step 2 is going to be to find the sign, S-I-G-N, either positive or negative. And step 3 is going to be evaluate. So step 1, the reference angle, we just said was pi over 4. And the sign, if we look in this quadrant right here, we see that sine, which is the y coordinate, is positive, because negative positive, cosine sine, so sine is positive, so our answer is going to be positive something, and then we evaluate a reference angle pi over 4 in the first quadrant. So I do trig hand, and I put down this finger, right? And so it's square root of, since sine is on bottom, because it's cosine sine is on bottom, it's square root of 2 fingers over 2, because it's always over 2. And there you go. Let's do the next one. Cosine of 2 pi over 3. So if I do cosine of 2 pi over 3, again, step 1 is to find the reference angle. Step 2 is to decide if it's positive or negative. And then step 3 is to evaluate. So first, here's 1 pi over 3, 2 pi over 3 is about here. And to get all the way over to 3 pi over 3, I guess we stop short 1 pi over 3, right? So if I stop short 1 pi over 3, that's my reference angle. And that means it's going to be this in the first quadrant. But to find if it's plus or minus, I look here. And over here in this quadrant, cosine is x, it's positive, and sine is y. Oh, I'm sorry, cosine is negative. So cosine is negative because it's the x coordinate in this quadrant. And y is sine, so it's positive. But here we're worried about cosine, so I know that my sine is going to be negative. So my answer is going to be negative something, but I evaluate my reference angle of pi over 3 over in the first quadrant. And we know that pi over 3 is the second finger. Is the second finger. 1, 2, 3. So if I want cosine, it's on top. So cosine is on top, so it's the square root of 1 finger over 2, so it's negative 1/2. All right. Now we do the tangent of theta. I'm sorry, the tangent of pi. So in this case, we have a quadrantal angle. So we don't really even need to think about reference angles, etc. Because for 0, pi over 2, pi or 3 pi over 2, or any multiple, if you end on a quadrantal angle, one that breaks up the quadrants like this, you can just look at your unit circle, radius of 1, and see what the x and y coordinates are. And since tangent, I have memorized, is sine over cosine, I know that I can just think about this as sine of pi divided by the cosine of pi. And so in this case, sine is 0 and cosine is negative 1. So it's 0 over negative 1, which is 0. Okay? All right. So then, now we have sine of 5 pi over 6. As always, first we find the reference angle. If I go all the way to here, that would be 6 pi's over 6. Go all the way around, that would be 12 pi's over 6. So I guess we see that we're going to stop short. So this would be 0 pi's over 6, 12 pi's over 6. This would be 3, right? So it's going to be somewhere over here where we stop 1 pi over 6 short. So if pi over 6 is my reference angle, then that means I come over here in the first quadrant and draw my pi over 6, and I'll use that in just a minute. So for the cosine and sine, in this quadrant, cosine is negative and sine is positive. So if you're asking me to talk about sine, I know my answer is going to be positive something. So positive is my step 2. Then step 3, evaluate this pi over 6 reference angle. So pi over 6 on trig hand is thumb, finger, finger, nubbin, finger. So we put down this finger right here, the ring finger. It's always cosine over sine. So in this case, it's square root of 1 finger over 2. So it's 1/2. Okay. So then I come back over here. All right. And now let's go cosine of pi over 2. Again, pi over 2 is just a quadrantal angle. It ends up on the axes and it breaks up the quadrants. So if I go this far and stop here, and I'm on the unit circle where my radius is 1, and the x-coordinate is 0, the y-coordinate is 1, and since cosine is x, this is just 0. And now for 3 pi over 2, I guess I would have my unit circle for 3 pi over 2, and what would I be doing? So for 3 pi over 2, this is 1 pi over 2, this is 2 pi's over 2, also known as pi, and this is 3 pi over 2. So on the unit circle, I guess I'd be stopping here, and if it's the unit circle, the radius is 1, and so the x-coordinate is 0, and the y-coordinate is -1. So since tangent is sine over cosine, I can replace tangent of 3 pi over 2 with sine of 3 pi over 2 divided by cosine of 3 pi over 2. So sine of 3 pi over 2 is -1, cosine is 0, and so that is undefined. Anytime you divide by 0, you get undefined. We'll have to find ways in calculus to deal with things like that, if we can at all. So sine of 5 pi over 4, again, pi, we're going to think of, since we're dividing by 4, I'm going to break up my pi into 4 pi over 4, and that means 2 pi becomes 8 pi over 4, and halfway in between 4 and 8 should be 6 pi over 4, right? So if I open up and I go past 4 pi over 4 and stop here, then this would be my 5 pi over 4. So that's where I'm stopping right here, 5 pi over 4, right? So if I stop right here, then step 1 tells me that my reference angle is equal to, well, to get back to the x-axis, it's pi over 4. So my reference angle is going to be pi over 4 in the first quadrant. Step 2 is what? Step 2 is what? To find out if it's plus or minus. Well, in this quadrant, cosine is negative and sine is negative because cosine is x and sine is y. So if you want sine, I say, look, it's going to be negative, right? So my answer is going to be negative something. Let's see what it is by doing step 3, and step 3 is to evaluate this reference angle in the first quadrant. So on trig hand, it's thumb, finger, nubbin, finger, finger, because pi over 4 is in the middle, and cosine's on top, sine's on bottom. I do square root of 2 fingers over 2, so it's square root of 2 over 2, and that's your answer. Okay. All right. Again, at any time, if I go too fast, you can always pause the video. If I've got cosine of pi over 6, now I'm going to take my pi and I'm going to break it into 6 pi over 6. So halfway in between 0 and 6 pi over 6 is 3 pi over 6. And then, so that means every time I go a quarter of the circle, it's 3 pi over 6. So I've got 3 pi over 6, and then 6 pi over 6, And then I guess this is going to be 9 pi over 6. And this over here would be 12. 9, 10, 11, 12 pi over 6. Right? So if I go all the way through 3, 6, 9, 10, 11, I guess I'd stop somewhere over here, right? At 11 pi over 6. And so how much does it take to get back to the x-axis? Well, I guess it'd be 1 more pi over 6, because 11 plus 1 is 12. So my reference angle is going to be pi over 6 in the first quadrant. So step 1 says, look, your reference angle is pi over 6. Step 2 is it positive or negative? Well, when you end up down here at your 11 pi over 6, in that quadrant, cosine is positive and sine is negative. So since you want cosine, I know that my answer is going to be positive in the first, second, third, in the fourth quadrant. Right? So if I've got a plus, well, the last thing I need to do, step 3, is to evaluate what's going on. So I look at my pi over 6, and on trig hand, that would be thumb, finger, finger, nubbin, finger. So this would be pi over 6 or 30 degrees. We know it's alphabetical cosine over sine. So it's the square root of 3 fingers, and it's always over 2. Okay? All right. And last but not least, we look at tangent of pi over 6. And so we draw a reference angle. And if I open up pi over 6, well, I guess my reference angle to get back to the x-axis is just that same pi over 6 in the first quadrant. So reference angle is pi over 6. And in this quadrant, cosine is positive and sine is positive because cosine is x and sine is y. But I know that tangent is sine over cosine, so that's sine of pi over 6 divided by the cosine of pi over 6. So I know that I'm going to have a positive sine and a positive cosine, so my answer will end up being positive. Now, if I do trig hand with pi over 6, it's thumb, finger, finger, nubbin, finger. This, again, is pi over 6. On top is cosine, so it is the square root of 3 fingers over 2. And on the bottom is sine, so it's the square root of 1 finger over 2, or 1/2. Right? And so now, if I take this, how do you take one fraction and divide by another? Well, you keep this, you change division to multiplication, and you flip the second. Keep, change, flip, right? Another way to think it is you multiply by the reciprocal of the second, right? And so then these cancel out, and you just get square root of 3. All right? All right. Arc length. Well, if you find the arc length with a radius of 5, this time we'll call it 5 meters, just to give it some units. Arc length, I will tell you on the exam, is S is equal to r theta, because we know the bigger the radius, the bigger arc you cut out. Because if I were to cut out a small radius with the same angle, it'd be a little arc compared to this big one. Or if you cut out a bigger theta, you would get a bigger arc. So S is equal to r theta, we believe it. So if S is equal to r theta, the only thing we need to be careful of, caution, theta in radians. That's the only way you can really screw this up. So if S is equal to r theta, the radius is 5 meters, and theta is equal to 30 degrees. Well, 30 is pi over 6. So that means we're going to have 5 pi over 6 meters. It's going to be my arc length. And you can leave that answer in terms of pi. Go up here to 26. Find the angle if the arc length is 2 pi and the diameter is 16. Well, arc length, again, is S is equal to r theta. If I'm searching for the angle, then that means I'm going to end up solving for theta. So I want to know what theta is. If the radius, well, if the diameter is 16, the radius is, 8, half that. So radius is 8. It says the arc length is 2 pi. So that means, again, a radius, maybe it's in, no matter what the units are going to cancel out. So let's say, for example, that was in meters, and this over here happened to be in meters. You see that the meters and the meters, when we divide, are just going to cancel out. It's going to be 2 pi meters over 8 meters, and they're going to cancel out, just in case you were worried what's going to happen with the units. Okay? So if we had to solve this, we would just divide by 8, and you're going to end up getting that 2 pi divided by 8 is equal to what theta is. In other words, pi over 4 radians is the angle you open up. Now it says find the area of the sector if the radius is 6. So I'll give you the equation. Is A is equal to 1/2 r squared theta. We saw in class where that came from. We derived it actually. So if r is 6 and you square it, and theta is 5 pi over 6, watch what happens. We get 1/2 6 squared times 5 pi over 6. Well, hey, one of these 6's cancel out, and you just get 5 times the 6 is left on top times pi with a 2 on the bottom, right? So one of these 6's cancels out and leaves you only 1 on top, this one here. The 5 and the pi and the 2 are still there. So now the 6 and the 2 cancel out and give you a 3. So it's 5 times 3. In other words, it's 15 pi. And guess what? We are not doing 28 and 29. So if you've completed the review, great work.